I am Hamida Rebai. Thank you for joining me today in Conf42 and welcome to my talk about architecting .NET microservices in Docker ecosystem. So who I am? I am Microsoft MVP in developer technologies, a solution architect, a member and speaker in .NET Foundation. I'm also MCT, Azure certified, and book author. You can follow me on Medium blog, LinkedIn, YouTube, or Twitter. Today, we will talk about microservices architecture, container and Docker. We will see the difference between Docker container, Docker image. We will set up our development environment to be able to test some demonstrations. So, what is microservices architecture? Microservices are the natural evolution of service-oriented architecture, but there are differences between microservices and service-oriented architecture. So we can talk about some characteristics related to microservices. In microservices architecture, services are small, independent, and loosely coupled. Each service is separate code base, which can be managed by a small development team. All services can be deployed independently. A team can update an existing service without rebuilding and redeploying the entire application. Services are responsible for persisting their own data or any external state. This differs from the traditional model where a separate data layer handles data persistence. Services communicate with each other by using well-defined APIs. Internal implementation details of each service are hidden from other services. Services don't need to share the same technology stack, libraries, or frameworks. Besides, for the services themselves, some other component appears in typical microservices architecture. Management of the component is responsible for replacing services on nodes, identifying failures, rebalancing services across nodes, and so forth. We can talk about the different elements related to microservices like service discovery that maintain a list of services and which nodes they are located on. It enables service lookup to find the endpoint for a service. When we talk about microservices architecture, we have another important element to understand, that is API gateway, that is the entry point for all the entire clients. Developers consider microservices as an architectural style that promotes the development of complex applications as a suite of small services based on business capabilities and multiple independent subsystems in the form of an autonomous services. The following pictures shows the microservices architecture style. There are various components in a microservices architecture apart from the microservices themselves. So we start talking about the management part that maintain the nodes for the services. We have also identity provider that manages the identity information and provides authentication services within a distributed network. Service discovery keeps track of services and service addresses and endpoints. Here we have the API gateway. It serves a client's entry point, the single point of contact from the client, which in turn returns responses from underlying microservices and sometimes an aggregated response from multiple underlying microservices. An API gateway sits between the clients and the services. It acts as a reverse proxy, routing requests from clients to services. It may also perform various cross-cutting tasks such as authentication, SSL termination, and rate limiting. If you don't deploy a gateway, clients must send requests directly to front-end services. It creates coupling between the client and the backend. The client needs to know how the individual services are decomposed. That makes it harder to maintain the client and also harder to refactor services. So the API gateway can perform other cross-cutting functions, as we said before, like authentication, logging, SSL termination, and load balancing. Let's now understand the role of an architect. An architect will define the software architecture of a computing system that presents a set of structures needed to reason about the system, which comprises software elements, relations among them, and the properties of both. This architecture should meet the non-functional requirements in development like maintainability, testability, or deployability, and in runtime like scalability, performance, and availability. The microservices architecture offer tremendous benefits, but it's not a silver bullet. It also has some significant drawbacks, and the microservices pattern languages is a collection of patterns that solve architecture, design, development, and operational problems. It enables software developers to apply the microservices architecture effectively. Containers combine an app plus its configuration and dependency into a single, independently deployable unit. Containers are an excellent fit for bundling and deploying independent microservices. Let's learn more about containers. Containerization is an approach to software development in which an application or service, its dependency, and its configuration are packaged together as a container image. The configuration can be abstracted as deployment manifest file, for example. The containerized application can be tested as a unit and deployed as a container image instance to the host operating system, just as shipping container allow goods to be transported by ship, train, or truck regardless of the cargo inside. Software containers act as a standard unit of software deployment that can contain different code and dependency. Containerizing on software this way enables developers and IT professionals to deploy them across environments with little or no modification. Containers also isolate applications from each other on a shared operating system. Containerized applications run on top of a container host that in turn runs on the operating system, Linux or Windows, for example. Containers therefore have a significantly smaller footprint than virtual machine images. Each container can run a whole web application or a service as shown in this picture. We have some examples here in Docker. With a container host, we can run the first application, another application, a service, and another service, for example. Another benefit of a containerization is scalability. You can scale out quickly by creating new containers for short-term tasks. From an application point of view, instantiating an image, it's like creating a container, is similar to instantiating a process like service or web app. For reliability, however, when you run multiple instances of the same image across multiple host servers, you typically want each container image instance to run in a different host server or virtual machine in different fault domains. In short, containers offer the benefit of isolation, portability, agility, scalability, and control across the whole application lifecycle workflow. The most important definite benefit is the environment's isolation provided between the dev and the operations. What is the difference between Docker container and Docker image? Let's start by Docker container. Docker container is virtualized runtime environment used in application development. As we mentioned before in the definition of Docker, with Docker we are able to create, run, and deploy applications that are isolated from the underlying hardware. A Docker container can use just one machine, share its kernel, and virtualize the operating system to run more isolated processes. So, Docker containers are lightweight. Docker image is like a snapshot in other types of virtual machine environments. It's a record of a Docker container at a specific point in time. Docker images are also immutable. While they can't be changed, they can be duplicated, shared, or deleted. The feature is useful for testing new software or configurations because whatever happens, the image remains unchanged. Containers require the existing runnable images to exist. They are independent on images because they are used to construct runtime environments and are needed to run on applications. You might want to use Docker containers just to simplify deployment even if you are not creating microservices. For example, perhaps you want to improve your DevOps workflow with Docker. Containers can give you better isolated test environment and can also eliminate deployment issues caused by missing dependency when you move to production environments. In cases like this, even if you are deploying a monolithic application, it makes sense to use Docker and Windows containers for your current .NET Framework applications. In most cases, for this scenario, you will not need to migrate your existing application to .NET 6 or 7. You can use Docker containers that include the traditional .NET framework. However, a recommended approach is to use the latest version of .NET 6 or 7 in our case, as you extend an existing application, such as writing a new service in ASP.NET Core. Let's prepare our environment for running containers locally, and for that, we need to follow all these steps. We need to install Docker Desktop. It's free and it's available for Mac and Windows. Use this link to be able to install the latest version of Docker Desktop with the latest updates. So we can open docker.com and we can click Download Docker Desktop. Here we can install it on Windows, Linux, or macOS. We need to install Visual Studio 2019 or the latest version 2022. We can also use Visual Studio Code. And to do that, we will go to the website of Visual Studio. And here we will use visualstudio.microsoft.com. Here we can select Visual Studio. We have many versions. We can use community version, it's really free. And we have professional enterprise. But in our demo, we can use only community version. We have also Visual Studio for macOS, for the environment of macOS. And here we can download Visual Studio Code, and it's available for Windows, macOS, and also for Linux. We need to have an Azure account where we are able to create an Azure container registry and any other Azure services. We will use PowerShell in Windows or Azure Cloud Shell using the direct link. You need to open your browser shell.azure.com, else you select the Cloud Shell icon on the Azure portal. We will see that in Azure after. If you are using Visual Studio Code, don't forget to add the different extensions like Microsoft C# for Visual Studio Code, Docker extension, and Azure App Service extension must be installed. As soon as our environment is ready, we will start with the first step, which is the creation of a Docker image of a web application that we will create it from an existing Visual Studio templates. This is the demonstration flow. We will start by creating and building a Docker image. We will see two methods, the first one using Visual Studio and the second using Docker command line. After, we will tag and push the image locally, and in the end, we will build and store images using Azure Container Registry, Docker App, and we will start discovering Azure Container Apps. After installing Docker Desktop, we will open it. It should be running. As you can see here, the engine is running. Here we have a list of containers that we will create it, and here we have a list of images. If you need to see more about the different settings, you click just here in this icon, and you have all information needed for Docker engine. If you need to enable Kubernetes, you just select here. The different extension, for example, here I enable Docker extension, the use of this extension. And here we have general information related, general settings related to Docker Desktop. Now we will open Visual Studio. This is Visual Studio, and we will create a new project. We will select this template, ASP.NET Core Web API. We can select Web API, for example, but in our case, we will select just Web API. We select Next here. We give a name to our application, we identify the location of our application, and we will select after next. And I select here next. Here we have to select the framework. It can be .NET 6 or .NET 7, for example. We select the latest version of .NET framework. I will disable the configuration for HTTPS. Here we are able to enable Docker or not. If it's not enabled, we can also add our Docker file. We see that after, but I will keep it enabled. We will select the Docker operating system, Linux or Windows. After we select Create button to be able to create our application. So, the first demo consists on building a Docker image. We will use Visual Studio, the previous solution that we created, the web application that we created. We will use also Visual Studio Code. Let's start now. We come back to our solution. In our Conference Manager project, we have Docker file that is generated automatically. As you can see here, we can add this file just by right-click on the solution. It's really simple. We select Add, and we select Docker support. Here we select the target, Linux operating system or Windows, and we click on OK, and the file can be generated also if we didn't enable Docker support when we created our solution, or if we want to add Docker file to containerize our solution in an old application. So let's try to discover this Docker file. We will start from this line from mcr microsoft.com.net SDK7 to tell Docker what image we would like to use to build our application. Docker images can be inherited from other images. Therefore, instead of creating our own image, we will use the official .NET SDK image that already has all the tools and packages that we need to build a .NET application. We will use multi-stage build as defined stage for building the web application. We define build stage in our Docker file using as. To make things easier when running the rest of the commands, we will use workdir with the source to create a working directory for our source files. This instructs Docker to use this path as the default location for all subsequent commands. By doing this, we do not have to type out full file paths, but can use relative paths based on the working directory. Although not necessary, the commands below will make a copy here, only the CS project files, and then run .NET restore. Each command creates a new container layers. To speed the building of containers, Docker caches these layers. Since these files will change often, we can take advantage of the caching by copying these files and running restore as separate command. Next, we will need to copy all the rest of our source files into the image. This line below will copy the files here from the source directory on your local machine to directory called source in the images in the local. So we keep the copy locally, and here in the end we need to run .NET publish command line to build our project. Let's go back to the first line. We will specify the image that we will use to run our application, and we will define our runtime stage. We will specify the working directory at this stage also, and we will expose the port 80 to incoming requests. We will use entry point to tell Docker what command we want to run when our image is executed inside the container. We do this using the .NET here and our DLL of the solution, as you can see here. And to make your build context as more as possible, we have inside this Docker ignore that includes all these folders. Now to build our image, it's really simple. We just select here build or rebuild to clean and build, and we will try to check Docker desktop if we have any container deployed or any image. As you can see here, we have conference manager. We will try to check our container. We need to run our solution to be able to have or to create our container and to see it in this place. So I will select Docker. It's really simple to run our solution and our container using Visual Studio 2022. And I will try to see here what happens. As you can see, we have container support. We can see our container. We can stop it. We can open terminal windows to see what's going on. And this is our application. It's a really simple application. Let's check Docker desktop here. And we see as a container already running here, we have the conference manager is created. Our container is created and we are able to see it here in using Docker desktop. Now we will open Visual Studio Code and we will create a new web API using .NET New Web API. Having created, I will close the terminal and we will use Ctrl-Shift-P command line if you want to see the different command line to create our Docker file, for example. Now I will open the folder and this is our solution. After we will select Ctrl-Shift-P to be able to add our Docker file, Ctrl-Shift and P. And we say Docker add file to workspace. We select this one. We select our framework.NET in our case, the operating system, the port needed, and we change it here. And he will ask me about adding Docker Compose. I will say maybe yes in this time. We will detail it after. This is our Docker file. It's more and more detailed, but it's the same concept. We use from, work dir, copy. We have the endpoints. So we using publishing, .NET Restore. So we have basically the same content as before. Now to build our image, I will open terminal, new terminal, and I will use this command line docker build t -t conference manager image, and I give version, let's say version, it will be a tag, we will see that after, and we enter here and it's building as you can see here. Now to run our container we will use docker run. This is the port number and our image that we already built it, and we select here and we will check in Docker here. Let's go back to images. We have our image conference manager image, and in container we have the name of this container as you can see here, and this is the image. I go back here. This is container created from our image. Now we will see how we can tag an image. The Docker tag helps maintain the build version to push the image to the Docker hub. The Docker hub allows us to group images together based on name and tag. And we have the same thing with the Azure Container Registry. Multiple Docker tags can point to a particular image. Basically, as in Git, Docker tags are similar to specific commits. Docker tags are just an alias for an image ID. Let's see now how we can use Visual Studio Code to add tags. If we come back to our solution in the terminal, we used a command line, this one, run. This is the port, and we used conference image 1.0. 1.0 is our tag in our case. But we can add more tags using Docker extension. As you can see here, we have the first tag, and we can right click on conference, and we add our tag by selecting tag. Here we select tag, and we can use this one, 2.0 for example, and we run it. As you can see here, we have our second tag. We will see in Docker if we have any changes related to the tag here. As you can see, we have the first one and the second one. Now to build and store our Docker images, we will use Azure Container Registry. So we'll open Azure Portal and we will create Azure Container Registry. After, we will deploy using Visual Studio 2022. Now we will create our Azure Container Registry using Azure Portal. Select Create a Resource. After, in Categories, we will select Containers. And here we have Container Registry. We click on Create. We have multiple tabs. We start by Basics tab. And here in Project Details, we need to define subscription, resource group, and the different elements needed to create our container registry, the name of our registry, location, availability zone, and here we select basic or standard or premium SKU. As you can see, I updated my page. If you are using a private IP, you need to select networking tab and you select private access. Here we have encryption. If you need to use customer manager key, you can enable it and use it. We can add some tags, and in the end, we will select review and create. As you can see, the validation passed after we select create. Even our Azure Container Registry is created, we will use here Visual Studio to publish our application in this registry. To do that, we select Container Manager, the project, right-click, Publish. Here we have multiple choices. We select Azure because we need to use the Azure Container Registry. You can also use the Docker Container Registry, all folder, FTP, FTPS server, alias, or just import profile. If I select Docker Container Registry, I will select Next, for example, and we can find also Azure Container Registry. In Azure, we have also Azure Container Registry. Here we have Azure App Service and Azure Container Registry. We can use also Azure App Service as a container if we need to just deploy one container. But if you have multiple containers, we need to add our container in Azure Container Registry. We select Next. And I need to check if our container registry is already created. As you can see here, it's already created. We go to the resource. Here we have the login server. We need just to check the repositories. We don't have any repositories. When we upload our application, we will see our repository and our container inside the repository. Let's go back to Visual Studio. Here we have Conference Manager. We click on Finish. After we select Close and we click on Publish to be able to publish our container in Azure Container Registry. It takes few seconds. Now we'll check Azure Portal to see our registry. And here we select repositories and we have our repository container manager, as you can see here. Now if we open Docker Desktop, here we can see our repository added in the list, as you can see here. We will use now Visual Studio Code to see how we can push our image to Azure Container Registry that we already created. We go back to Visual Studio Code and we will use the Docker extension as we did before. And here we can see all the registry. We have Azure or Docker Hub. I will select the second one, this one. I will say push, for example. and I will select Azure. I have a list of the registries inside my Azure account. I will select Conference Manager, and we will use the tag image, the same tag image. We not made a change here. And here, as you can see, it takes few seconds to be pushed to our registry, and we check after in Azure Portal I will finish it. I will open Azure Portal, and I will go to repositories, and we find the Conference Manager image using our tag. As you can see here, this is the tag. If we check Docker, we are able to see also the image here, Conference Manager image. If you need, for example, to push the first tag, we see how we can proceed, what is the result. I will use the same tag for the same image. Let's go back to Azure Portal, repositories, and here we will check, take the first one, the second one. As you can see here, we have the fourth project we created using Visual Studio 2022, and this is the second project used Visual Studio Code. Here we have only one tag, latest, the default one, use the default one, and here we have two tags. To create Azure Container Registry, we can use Azure Portal, Azure CLI, Azure PowerShell, any template, ARM templates. In our case, we just tested the use of Azure Portal. We can use Azure CLI, so I will just go to shell.azure.com. I need to be authenticated to my account, and we use this command line ACR create. I will define our resource group. I will use the previous created one, the name, and my plan. I select enter, and in a few seconds our Azure Container Registry will be created inside the same resource group. It's running now. And as you can see here, we have a JSON file as a result. And I will check in my resource group the different resources created here. And here I have my container for conference that present our container registry. As registry, we are using Azure Container Registry, but we are able to deploy our image, our container image, to Docker Hub, that is a public registry. And to do that, it's really simple. We can use the same publish. Here, I will select a second one, for example, here, a new one. Here, I will select Docker Container, and I will select Docker Hub. As you can see here, we are able to publish our application as a Docker image to any container registry in the cloud, in-prem. So you need just to define the path of your repository. Now we select Docker Hub. We click on Next. We need to add the username, the password. After we click on Finish. As you can see here, we click it on Finish after we select Close and we select Publish. It takes few seconds to be published to Docker Hub, and we will try to check Docker Hub to see if our container image was pushed or not in Docker Hub. Now, if I open Docker Hub using hub.docker.com, I'm using my personal account, and we can find my container image Conference Manager. If you are using Visual Studio Code, we can also publish our image to Docker Hub. So, for example, let's select this one, and we click Push. And instead of selecting as before Azure, we will select Docker Hub. I select my own account. If I have multiple accounts, you can select the convenient account needed. I leave the same tag after. It takes few seconds to be run in this way. If I go back to my Docker app, we can find the conference manager image. Let's open to see some description. Here we have the tag, as you can see, the first one. As you break down your monolithic application into separate, closely coupled microservices, your team will gain more autonomy and freedom. However, they still have to closely cooperate when interacting with the infrastructure the microservices must run on. You will have to solve problems like predicting how much computing resource each service will need, how these requirements change under load, how to carve out infrastructure partition and divide them between microservices, and enforce resource restrictions. Kubernetes or Orchestrator solves these problems quite elegantly and provides a common framework to describe, inspect, and reason about infrastructure resource sharing and utilization. That's why adopting Kubernetes as a part of your microservice re-architecture is a good idea. Microsoft Azure offers many options to work with containers and orchestrators. We used it before Azure Container Registry to store and manage our private container image. We used also Docker App for public images. Azure Container Instance or Azure App Services can be used to run isolated containers. We have also Azure Kubernetes Service that is a great option for more complex scenarios in which full container orchestration, automatic scaling, and service discovery are required. The problem is Kubernetes is extremely difficult to use, and we have another service that is Azure Container App. If you need to learn more about building modern applications using microservices, containers, Azure Services, Orchestrator, you can see these books on Amazon. And if you have any questions after this session, you can reach me by email, via Twitter, LinkedIn. Thank you for joining me today.